I'm covering two homework problems in this video. The first is fairly simple. It's using a graph right here and solving this inequality f of x less than or equal to 0 using both interval notation and a number line. The second problem is a little more involved because there's no graph given to you. You're going to have to draw this quadratic function using factored form and vertex form to help you through the picture. And then we'll do those same ideas again, solving it using interval notation and a number line. So if you're only here for the second part of this, the more complicated one, maybe zip ahead a minute into the video. Let's solve this first one. You'll notice that this is an inclusive inequality. In other words, it's less than or equal to. That or equal to makes a big difference in how we write the solution to it because it means these x-intercepts will be part of the solution to. That's what or equal to refers to, x-intercepts. So I have places where the y values are negative. That's this over here. And I would write that the following way: negative infinity to negative 4. Parentheses on the negative infinity, because you always have parentheses on negative infinities. You can't touch infinity. But we can touch negative 4. It's an x-intercept, and it's allowed because this is an inclusive inequality. So that gets a hard bracket. And then we look for another place where it's negative. I don't see any, but I do see another x-intercept where the function is equal to 0. And that's, remember, that's allowed. Equal to 0 is okay. So I would say union, and then a square bracket, 2, 2. Now, the reason it's 2, 2 is just because the computer always expects minimum, maximum, right? Min, max. And if you just say bracket 2 and close the bracket, the computer's going to think you're dum-dum. The computer's the idiot. It's not you, but we just have to work with it. Now, the way you write this as a number line solution is the following. You would put your x-intercepts on here using the dot because it's an inclusive inequality. And then once you have those, you just use this ray line to say, oh yeah, and also all that negative stuff. Okay, so that's how we write our inequality solutions. Coming over here, what's more difficult about this part of the problem is you have to actually factor this, put it into vertex form, draw it, and then we can get back to that stuff about solving the inequality. So factoring it, I hope that's not too bad, but possibly this negative sign right here is going to throw you off. I personally do not like negative signs, and I will always rewrite my polynomials with the negative sign factored out before I even start the factoring. So I see this is now negative times x squared minus 2x minus 3. Okay, and I find it easier to factor in that form because it's going to have a negative on the outside. But to me, this just looks like x minus 3 and x plus 1. Okay, and if you work that backwards, you can get back to the standard form by multiplying this all out. Now, the vertex form takes a little bit of thought, and the way I want to do this one, we've talked about vertex forms before, and I'm just going to use this graphing window here to draw on because I think that'll be helpful. First, let's write the standard form again. Negative times x squared, and I'm going to focus on part of this first. X squared minus 2x has my attention right now. And then I'll also have to deal with that minus 3. But first I want to focus on x squared minus 2x. And this is where completing the square comes in. I'm going to turn x squared minus 2x into something like this. X minus something squared. Well, how do I know it's x, first of all? How do you know that's an x that goes right here? And I'm going to point you to where I'm talking about, right here. Why is that an x? Well, if you think about it, x times itself gives you the x squared. That's the only way you're going to do this. It wouldn't be a 2x there. It wouldn't be a 3x. It has to be a single x. And now, what fills in the rest of this? Well, you could imagine putting a number 4 here, and if you multiply this out, you would get x squared minus 8x. That's not great. We're looking for a minus 2x. So 4 is not the number of choice. You could guess your way there, or you could just say negative b divided by 2a. Remember that trick? H equals negative b over 2a. That's useful here. That gets you, without guessing, to the answer. So that has to be x minus 1 right there. But, as is always the case when you're completing the square, we're going to introduce an error when we do this, which is when you square this last part, the minus 1 times minus 1 is plus 1. I didn't want a plus 1. So we have to subtract that off again. minus 1. And now I'm going to fill in the rest of the parts of this. I still have that minus 3. I still have the negative sign on the outside. So what's left once I, work through everything else? I have a negative. I have x minus 1 squared in a parentheses right here, and I have a minus 4. So if you want to maybe cut down on the parentheses a little bit, you could write this as negative x minus 1 squared and then plus 4 right there. Okay, so that will be our our vertex form, and I'm just going to write that right here. Actually, let's just grab this guy and put it in that box. Okay, great. And now we can get on with the graphing of this thing. So the graphing is fairly easy if you know what parts of the graph come from what parts of the equations. Well, here's the y-intercept. This guy right here. That's my y-intercept. So we can put that right there. Now, where are the x-intercepts? Those are these guys right here, except the sign is flipped for reasons we've talked about in class. So I've got an x-intercept at 3 and an x-intercept at negative 1. Okay, now where's my vertex? That's another interesting point. The vertex is going to be located at h, comma k. Okay, that's h, that's k. So the vertex is located at negative 1 in x. Let me see here, hold on. Okay, so positive 1 in x, because that's another sign flip. Positive 1 and positive 4. So there's my vertex. So I should write this circle a little differently. There's h right there. Remember, it's x minus h. So now let's just connect the dots. The way you would graph it is first you would, oh, that's a terrible looking parabola, but you get the idea. First you would use this little tool here, put a dot on the graph, and then stretch it out until it has the right shape and it hits those x-intercepts, y-intercepts, and the vertex correctly. So now we're going to solve it using interval notation. And you can either use the graph that you just came up with, maybe submit this question early, see if your graph is right, and then use the graph. Or you could go through a different process, creating a sign table, which we've talked about in class. But I'm just going to use the graph here because it's quicker. So f of x less than 0. In other words, all the places, all the places where the y values are negative. See, those are these ones. So that's going to be, from the looks of it, negative infinity to negative 1. And it's less than 0, that's exclusive in this case, meaning x-intercepts are not allowed. So that's a parentheses. And then union, where else is it negative? Well, looks like x equals 3 out to infinity. Again, exclusive. And the way you draw that on this graph is to come over here, use the dots, the open circles, I mean. Put one here and one here, and then just fill in some arrows for the rest of it using the arrow tool right here.